This is the factor review for the bottoms-up method. Okay, so for with bottoms up or any method when you're factoring, you want to first check and see if there's a GCF, a greatest common factor in the problem. If there is, you need to take it out and then continue to do what I'm going to show you here in a minute. So for number 1, 3x squared plus x minus 10, is there a GCF between 3, 1, and negative 10? Other than 1? No. So we can skip that step. So for this question, you take the coefficient on the square times the constant. So we're going to take 3 times negative 10 off to the side, and that's negative 30. You need to find factors that multiply to negative 30 but add to positive 1. What multiplies to negative 30 but adds to positive 1? 6 and negative 5, right? So for now, you write x plus 6, x minus 5. Order doesn't matter. You could have switched this around, but I'm not. So with this, obviously we're not done. If you were to FOIL this and go backwards, x times x gives you x squared, not 3x squared. So when you do bottoms up, you have to divide by that coefficient in front of the x squared. So you have to divide by 3. When you do that, if it reduces, you need to reduce it. What does 6 over 3 reduce to? 2, right? Does 5 over 3 reduce? No. So bottoms up. Bottoms up. 3x minus 5. And that's it. Super easy, kind of fun, right? Number 2, 3x squared plus 15x plus 18. First, check for a GCF. 3 goes into all of those evenly, so we need to pull that 3 out first. We need to factor out the 3. What's left over when you factor out the 3? X squared plus 5x plus 6. So we know that no matter what, our answer is going to have a 3 in front. So what I like to do is just kind of skip down a bit and show what my final answer is going to look like, but then I ignore the 3 for right now and I just focus on the x squared plus 5x plus 6 because I feel like it's confusing when you leave it all together. You do whatever works for you though, just don't forget the 3 at the end. So now this is just like that first problem. I want to take the coefficient on the square times the constant, so 1 times 6, which is obviously 6. What multiplies to 6 but adds to 5? 2 and 3. So you're going to write x plus 2, x plus 3. We have to divide by that 1 in front. When you divide by a 1, does that really change the problem? No, it's still x plus 2, x plus 3, right? So you end up having 3 parentheses, x plus 2 parentheses, x plus 3. So there's a nice little trick there. If there's ever a 1 in front like this, there's something that I say. It's if there's a 1 in front of the square, the answer is the pair. So if there's a 1 in front of the square, the answer is the pair. You don't have to do any extra work by dividing by that number in front. Just don't forget the 3. Let's try another one. X squared plus x minus 12. GCF, other than 1, no. So 1 times negative 12 is negative 12. What multiplies to negative 12 but adds to positive 1? 4 and negative 3. So you write x plus 4, x minus 3. If there's a 1 in front of the square, the answer is the pair. You're done. This one, what multiplies to 45 but adds to negative 14? Because there's a 1 in front of the square, the answer is going to be the pair. I don't even need to do that off to the side. What multiplies to 45 but adds to negative 14? Negative 9 and negative 5. That's it, you're done. Last question. This is the kind of thing you need to start recognizing. This is called a difference of squares. This is a perfect square, and this is a perfect square, and it's a difference because of a subtraction sign between them. So the shortcut to that is you take the square root of both of those. So the square root of 4 is 2. The square root of x squared is x. The square root of 9 is 3. So if it's a difference of squares, they get different signs. 2x minus 3, 2x plus 3. But I'll show you bottoms up just in case you forget that. So this is really 4x squared plus 0x minus 9. So you want to take 4 times negative 9, which is negative 36. What multiplies to negative 36 but adds to 0? Well, 6 and negative 6, right? So you would write for now x plus 6, x minus 6. Divide by that 4 in front. If it reduces, reduce it. So that reduces to 3 halves, and that reduces to 3 halves. So now, bottoms up, 2x plus 3. Bottoms up, 2x minus 3. That's it. If you have any questions, let me know.